Hello everyone. Let's learn about virtual machine scale set today with a practical scenario. Scale set is a service of Azure which deploys a set of identical VMs to address scalability issues. The prime feature of this service is when there is demand, my VM count goes up. Once the traffic comes down, my VM's count also comes down. Let's take a practical example of booking railway tickets in India. Tatkal non-AC starts at 10 a.m. and AC starts at 11 a.m. If IRCTC is managing the normal traffic with 50 servers, for Tatkal we need 150 servers to handle humongous amount of volume. But only for 2 hours, no organization wants to spend a capital expenditure for extra 100 servers. This exact pain point is solved by virtual machine scale set. Let's create a scale set and induce artificial traffic and see how the scaling happens. In the portal, I have a resource group and VNet. Type virtual machine scale set in the search bar and choose the VMSs. Give a name to your VMSs and choose the operating system of your choice. Every resource must be under one resource group. Give the login credentials and make a note of them. That's my username. And confirm the same password without any typo. Let's start with the minimum instance count of one VM. Here comes the most important part of VMSs, autoscale. It can go up to 1000 instances, but I need only 5 of them. When the CPU threshold goes beyond 75%, there should be +1 from the original instance, and when it comes down below 25%, there should be -1. As and when the scaling happens, we need all the VM instances to be under a load balancer. Hence, let's define the load balancer options. At last, place this VMSs inside a VNet that we created. We must also enable necessary ports for communication, and we are good to go. This creation usually takes up to 5 minutes. Our VM scale set is ready. Let's log into the VMSs that we created, but via the load balancer IP. Load balancer is created as a separate resource within the same resource group. Go to inbound NAT rules and we must log in via this port. However, we haven't enabled these ports. Let's go ahead and enable them in the network security group, which is again another resource under the same resource group. Go to the inbound security rule. 50,000 is the first port number. Let's type in the same number. Let's keep all the other options as they are. Give a name to the rule. We need to follow the same procedure to add port number 50,001 as well, and give a different name for this. Let's go back to the load balancer and get the public IP. Please watch carefully. In the RDP window, type in the public IP colon port number, that's 50,000. Let's give the same login credentials that we have set. There we go. We will be inside our server any minute. Once we are inside the operating system, for our convenience, let's disable the IE Enhanced Security configuration, which is not recommended for the live environment. Now it's time to simulate the CPU usage to more than 75%. Let's use the CPU stress tool, which is available in the internet. Just type in cpustress.exe. It's just one S. That's the blog that we are looking for. And this is exactly the tool. Let's download and run. What we are trying to do here is stress the CPU of the VMSs that we have created and see if the scaling happens from 1 to 5. That's the tool. Let's keep the workload maximum for all threads available. That's the last one. Now let's go back and monitor the traffic from the Azure portal. Go to the overview page of the VM scale set. In the left-hand side, choose Instance. It shows 1. And under Scaling also, it shows 1. Let's go back to the overview page again to monitor the CPU utilization. The traffic started hitting maximum CPU utilization. In our case, it is nothing but the passengers who are trying to book Tatkal train tickets at 10 a.m. Do you see under Instances, Azure is creating few more VMs for us to handle the traffic. We have 2 instances now. Good. Let's refresh. And there we go, the third one. Let's go to Instance, and there we can clearly see Azure is preparing all our 5 VMs that we asked for. We have 3 instances up and running and 2 more getting created, which will be up any minute. Let's again refresh here. Oh, there we go, 4. The last one. Fantastic, isn't it? Let's go to our VMSs and bring the traffic down, which means the Thatkal ticket booking period is over and the traffic is coming down. Now this should reflect in the portal as well. Let's go to the portal. We need to give few minutes to see the updated traffic. Make a note of my local time for your reference. There, the traffic came down. The instances are also getting deleted, all one by one. Let's refresh and give few more minutes. Finally, it's back to its original instance count, which means the traffic is normal. I hope you have a basic understanding of how a VM scale set works. Click Azure Monitor. Let's assume that the scalability happens when the Azure admin is not in front of the system. The admin can check the activity log of all the behavior that we had just experienced during the process. Also, there is this option to set alerts so that admins get an SMS or email notification when the CPU utilization hits high. Here ends the concept and demo of virtual machine scale set. Thank you.